Mr. Minnick helping my students in Python learn how to trace code that involves lists and loops. Here we have a list named scores, and the positions in that list are simply 0, 1, and 2. So for example, we could annotate that by putting a 0 there, a 1 there, and a 2 there to keep track. This line of code here that I need to execute, it's saying, hey, print whatever's in position, scores, square brackets, 0. So we go to scores, we find position 0, which is always the first element from left to right. And the 80 is what's printing out there according to that order of operations. So 80, I would like it to be written here in the answer blank on this particular worksheet. Number 2, position 1 is the 90. So the 90 there prints out. And I'll let the people watching the video do exercise 3 on their own. Next up in this section of the code, I have a variable called sum. I should probably, to be safe, keep track of sum with a little column. It's equal to 0. And now we hit, for the first time on this worksheet, a for loop. A for loop generally uses the loop variable named I. It doesn't have to, but it usually does in my way of teaching it. So I here, I starts at 0. We learned this in an earlier chapter, but when you have range 3, that means I starts at 0. Now we execute this inner body line of code. This means take whatever's currently in scores I. Scores I. Well, I is currently 0, so think of that as a 0. And that means you go to position 0 and you pull the 80 out. And so we really have an 80 there. And that 80 is being added into sum. So I put an 80 there because I added 80 plus 0. The grand total is 80. And now we're finished with this. So we erase it all. Hopefully my eraser works. And we go back up to the top of the for loop because, again, that's how it works. But when you go back up to the top of the for loop, you adjust I by bumping it up by 1. And then you go through the loop again. This time through the loop, we are pulling out the 90 because it's in position 1. And it's really a 90 that's being added into sum because of the plus equals operator. So 90 added to that makes a grand total of 170 so far. Then we loop back up again. We erase everything for another go around if necessary, another iteration as they call it in computer science of a loop. And I bumps up to 2. Yes, 2 is indeed less than 3, so we go through the loop again. And we work again from right to left. But what is this here on the right? Well, we got to go check the updated value stored in I. I is currently, you see, a 2. So think of that as square brackets 2. But scores, square brackets 2, in turn, tells you to come up here to scores and go find whatever number is in position 2, the 80. So it's really as if we had an 80 there being added into sum. 80 plus 170 is 250. We now are finished with that particular step. We loop back up to the top of the loop. Hopefully this is not an infinite loop because I would never finish this video if it were. But let's see what happens. The next time to the top of that for loop, we again bump up I to the number 3. And look, it says to stop at 3 because that's the way the range function works. In fact, if you want to get technical, I never hits 3. It actually stopped at 2, and that's the number that should be circled because often I see, not in this version of the worksheet, but often I tell you up here in the directions to circle the final value of any variable that you traced. So the final values under I and sum are 2 and 250. We are done with the for loop. We execute this line of code because it's not indented. It's not indented, so it's not part of the for loop. And we print sum, which happens to be 250. So that's as if there's a 250 there. And that's what I want on this worksheet. So I'll give you that one for free. I didn't do number 3. You can do that on your own time. This one right here. This one is a little bit harder because it's a linear search we're looking for the number 90. Now you can eyeball this and see that the 90 there is in the middle, and that found 90 will eventually print. I'm going to put a wrong answer in here for now, so that anybody listening to the video knows that that's the wrong answer. Found, do you see the word yes in double quotes? No. So it's impossible for it to print the word yes. It's going to print found 90, not yes. It could print yes if I had the word yes in there. Anyway, trust me that when this for loop iterates 3 times, like this one did up here, from left to right, we will find that 90, because the variable I, like it did up here, will go from 0 to 1 to 2. And at some point, this double equals will be true, and we will execute the print statement. But there will be 2 times where we won't execute the print. When we hit these 80s, of course, it won't. The only other thing that I want to say about this incomplete exercise evaluation is that instead of hardwiring it with range 3 here, I did range len scores. You all know that len means length in Python, and the length function simply goes to the array, the list name scores, and the length, Elijah knows that the length of that list is 3. It's 3. It's not 2, like some people think it is. Okay, I'm going to pause now so that the students in 2018 can ask questions, and maybe I'll come back to the video, maybe not. Okay, fast forward. I'm back in action here. Mr. Minnick again, just in case you forgot who I was. Here we have scores being equal to 5 elements. The length of scores is a 5, so I'm going to put a 5 down here, switching to the color red just because. So len scores right here is a 5, and because of the range 5, I can just tell you that I will end up starting at 0, and it's going to go up to 4, ... I just want to give you a preview of things to come. I'm not going to trace this one out step by step. So in this code segment, I is going to go from 0 to 4. And again, with an if statement, we are going to do what's called a linear search. And we're going to go right down the line from left to right here, from positions 0 up through 4. And what are we looking for this time? We're looking for a key. But key doesn't have double quotes around it. Key is the name of a variable that you can see right here was previously set equal to 75. So in this exercise, we're looking for the number 75, not the number 90 like we were up there. Who in this room silently, because I don't want you talking on my video, who thinks it's better to use a variable in a double equals find situation instead of just hardwiring your code in the most cheesy way with a number stuck right in that if statement? Who thinks that having this more user-friendly variable name is better than this way? Raise your hands. Only 3 people. That's disappointing out of about 20. You would have thought when I said that this was cheesy up here, people knew that that's not the best way. No, that's horrible, 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 horrible. This is more professional. Anyway, this one is going to find 75. 75 is right there. And it will print the position of where it found it. It found the I. It found 75 right there. Now, some people think that's position number 2. So I'm going to, again, put the wrong answer here. Found. I'm using a mouse. This is taking a while here. This is as bad as a stylus. Or using your finger as a stylus on an iPad. Found 75 in position 2. It's going to be so wrong because it's officially in position 1, since you know that lists always start at 0 there. It's position 1 that should be the answer, but I'm putting a 2 there. That is so wrong, just like that yes was wrong. Does anything else print? No, because there are no other 75s. So only that one printout will show up because of this red code. Moving on to this next one, which is warning you it's tricky. I'm going to number the positions there, 0 through whatever again. I'm going to set the variable max equal to 0 just to be safe, just like I did with key equal to 75 up above. Stop making the noise to my left. We have another for loop and another if statement. It's also known as a sequential search. Linear searches are called sequential searches because you're going in sequence from left to right. Usually left to right. Not always, but usually. Okay, what are we doing here? We're checking to see if something is greater than something. Well, pretty much every number is greater than 0, every positive number. So 65, when I start at 0, 65 is indeed greater than 0. So that means we do execute the indented line of code under if. So what is this line of code telling me to do here? Well, tricky I means go to position 0 of the list tricky, and that would be right here. Take the 65 out of there, and that 65 that I'm carefully, Pedro, writing in there, that 65 plugs into max. It plugs into max. There's nothing funny going on in this room right now except for my mouse that's on the screen right now. This is not a plus equals. Up here we saw plus equals, which caused a running total to be added up. Down here we don't have a plus equals. We have a straight equals, which means we're overwriting the 0 with 65 because that's the new max. Then we loop back up to the top of the for loop and we bump I up to 1. And erasing this, because we always use pencil, erasing all of this for another iteration, we carefully, using green now, we carefully look to see I is currently 1. Because there's a 1 in the square brackets, that means you come up to position 1 here of tricky. You take that 75. The 75 is kind of like by substitution, like an algebra teacher would call it. The 75 is plugged in there for tricky I. That's really a 75. And we're asking if 75 is greater than max. Max used to be 0, but it's not anymore. It's 65. Is 75 greater than 65, I'm asking? True, capital T. So we do indeed execute the line of code that's inside the if statement. We do execute this, and we know it works from right to left. Again, there's nothing funny about this. So it's a 65 that we currently have in tricky I. It plugs in, it's a 75, my bad, 75. It plugs in the max. It overwrites this 65. It doesn't add to it. Bye-bye, Max. It was nice knowing you, 65. New boss in town, 75. Just saying. We don't print anything out yet because we're still tied down in this loop. We go back up to the top. We erase everything from that go around. Now be careful here because this is the tricky part. I bumps up to 2. We are now checking to see if 90 is bigger than max. Is the 90 bigger than this 75? It sure is. So 90 goes from tricky I, it plugs into max. By 75, you're now 90. We go back up to the top of the for loop, and guess what? Because we bump I up to 3, it stops. It technically doesn't actually hit the 3 like I explained earlier in this video. It stops at 2. If you had to circle this, you would circle the 2, you would circle the 90. The answer here is 90 is the max. I would like to write that, but again, I'm putting a wrong answer on purpose. I'm writing 95 is the max because we did not go the full way up to the length of that array. It's a total logic error, probably. The coder should have put the number 5 in there or len tricky. But because he or she put 3, this is a wrong answer. It should be 90 is the max. Now, you all should do this one on your own. I think we're looking for the smallest number. Again, I used 4 there. Be careful about that. This one might be tricky also. Good luck with that. I look forward to getting the submitted worksheets tomorrow.